A lot here. We learned that you can use custom auth claims as a server verified way of adding roles to a user. You can set values within your database for a more flexible way of adding roles and then use get to fetch those documents. You can create functions for cleaner, reusable, and easier to read code. Security rules support lists and sets with helpful functions like in, has only, and has all. You can use let to define variables within a function. Debug is a great way of spitting out values to your debug log. And map diffs are a great way of seeing what's changed between two different maps, like say your request.resource.data object and your resource.data object. A lot here. We learned that you can use custom auth claims as a server verified way of adding roles to a user. You can set values within your database for a more flexible way of adding roles and then use get to fetch those documents. You can create functions for cleaner, reusable, and easier to read code. Security rules support lists and sets with helpful functions like in, has only, and has all. You can use let to define variables within a function. Debug is a great way of spitting out values to your debug log. And map diffs are a great way of seeing what's changed between two different maps, like say your request.resource.data object and your resource.data object. Rules, but want to get into some more intermediate levels like querying other documents or limiting access to certain fields? Well, have I got a video for you? It's this one. Let's get started on this episode of Firecasts. Hi there, Firebase developers. So this video is a bit of a continuation of our last one where I showed you how to get started unit testing your security rules with the Firebase emulator suite. And this is definitely a practice I recommend when developing security rules. They tend to lend themselves really nicely to unit testing, and it's important to get them right. So even if you're not unit testing your entire application, you should at least unit test the security rules portion of it. So if you're not familiar with unit testing your security rules, I would definitely recommend that you watch that first video and then come back to this one. Just go ahead and pause me, I won't be offended. Otherwise, here's where I'm at right now. I'm working on a hypothetical social app that's got a user collection, a post collection for user posts, and a read-only collection. And I've set up my security rules to make sure that my read-only collection is read-only. You can only write to a user document with the same ID as your user ID, and you can only read posts that are marked as public or you're the author. And then I wrote a few simple unit tests to test most of this stuff. So let's move on to some more complex security rules, and we'll start with one very common request, role-based security. I'm going to do things a little out of order here. Let's skip over the rules for creating a new post for now, and let's just say that once a post has been created, you can go ahead and update it, but only if you're listed as the author. So the rules look like this. You can update a document if the value of the author ID field in the post document is equal to the verified user ID in Firebase Auth. Now, the tests themselves aren't really going to be anything different than what you've seen in the last lesson, but since that was a few weeks ago, let's review setting one of these up. As with most Mocha tests, I'll want to start with the it function, and I will say that my application allows a user to edit their own post. Then we'll set up our asynchronous callback. Let me create a constant to hold the ID of our post document, and then I'll say that admin equals get admin Firestore. As you recall, this is a function that returns a version of Cloud Firestore instantiated through my firebase.initializeAdminApp function, meaning that it's kind of like a pseudo app that gets to ignore security rules. Perfect for setting up test documents in my database. Oh, by the way, some of our engineers would like me to point out that this isn't really using an actual server-side admin SDK. It's more like a special version of our client SDK that's allowed to bypass security rules only for unit testing purposes, but it's definitely good enough to set up some test documents. So I'll use that to create my test document, one in my post collection with the ID of that variable I set earlier, and we'll add in some basic content, and most importantly, make sure the author ID is equal to my ID. Again, as a reminder, this my ID is a constant that I use throughout my tests to represent the ID of our theoretical user, good old user ABC. This is an asynchronous call, so we'll need to add an await here. Next, I'll set db equal to get Firestore with my auth. As you recall, get Firestore is a function that returns another Cloud Firestore app, but just a regular old client version, not one with super user powers. And by passing in the myAuth auth object, I'm able to get a version of Cloud Firestore that acts as though I'm logged in as this user. So now I can set my test doc equal to the doc I created earlier in the post collection. Just now I'm accessing it as user ABC. And now I'm going to try to update the content of this document. And because I'm the author of this document, I'm going to assert that this call should succeed. And again, if any of this seemed confusing, go back to the first video where I explained this in a lot more detail. So let me run this, and it works. And then I can create another test to make sure you can't edit somebody else's post. Note the author ID now of the document is their ID, and that I am asserting fails here at the bottom. So I'll run this, and this passes too. So this is fine, but not really anything different than what we've done before. So let's move on to something more interesting. Let's say we want to label some users as moderators. And if you're a moderator, you have the ability to edit any post. Now, there's lots of ways of doing this, but I'd say two of the most common ways are either using custom auth claims or adding our user to like some kind of admin list elsewhere in our database. Let's start by trying that first option. Now, custom auth claims are pretty neat. But for good explanation, let's ask Rachel Myers, Developer Programs Engineer on the Security Rules team. Hi, Rachel.
Database. The custom auth token is going to be included in that auth object that accompanies the database request. In your security rules, you can check for the presence or the value of any of the custom claims, just like you might already check for the user's user ID.
Oh, and so that means I can trust it then too, right?
Yes. Because this value is part of the ID token signed by the Firebase servers, you can trust these values the same way that you can trust the user's ID. Remember that custom auth is different than custom claims. Custom auth is when you have an existing system that users are already signing into. Custom claims are for when you want to attach specific permissions onto the user's token. In both cases, you can trust the user's ID token.
Okay, good clarifications. So let's try using our custom claims. So you recall that up until now, we've been setting our user's user ID and email in this fake auth object. Now, it turns out I've been leaving out one minor detail. I can access our user's UID through the request.auth.uid value in our security rules, but it turns out this is kind of a bit of a special case. Other values like email, along with any other custom claim, would be accessed through a request.auth.token object. So if I wanted to test our user's email address, I would run a test against request.auth.token.email. So going back to our example, if we want to label some of our users as moderators, we could do that by setting like an is moderator equals true kind of auth claim. Since I'm attaching an attribute to my user, this is sometimes called attribute-based access control, or ABAC. You could also do this by having a role equals moderator kind of auth claim. This would be role-based access control, or RBAC. Both these work in Firebase. Which one you choose kind of depends on like how many kinds of roles or levels you think you're going to need within your app. I'm going to try that first option for now. So I can set up security rules to support this new use case by saying we'll allow an update if the user is the author, or if request.auth.token.isModerator equals true. Although I suspect this is a test I would use often enough in my app that it might be worth pulling out into its own function like this. Security rules allow you to write your own custom functions, and it's a good way to handle rules with sections of code or just complex bits of logic that probably should be abstracted away. And that makes this rule a little cleaner and easier to understand. So to test it, we'll start with kind of the same test as before. We'll create a document written as our good friend their ID. Then I'm going to need to set db equal to get Firestore, but I'm going to need a new auth object here, one for my special moderator user. Since I suspect this will play a role in many other future tests, I will stick this up here with my constants. So let me give them a user ID of user mod, and I will create an auth object with that user ID I just set, an email, and most importantly, is moderator set to true. So now going back to my test, I will set db equal to get Firestore with this mod auth object. Then I'll once again attempt to alter this test object, except now I'm expecting that this call succeeds. So let me run it again, and hey, wow, it passes. So custom auth claims are pretty useful. Seems like I could use them everywhere in my app.
Well, hang on. You should know there are a few restrictions on custom claims. You're only allowed 1,000 bytes of custom auth data. And custom auth claims have to be set using server-side code, like with a cloud function. Because this needs to happen in a trusted environment, you can't set this data using client libraries. And finally, custom auth claims are not applied right away. You generally need to wait for your client SDKs to refresh the user's Firebase token, and that happens every hour.
Okay, that does seem a little limiting. So when's a good time to use them?
There's always a choice to put something in your database or in a custom claim. Use custom claims to flip a permission-related bit or for settings that will change infrequently. For example, setting your support team to be moderators or upgrading a user to a premium membership. But for settings that change frequently or are used for anything other than permissions, it's better to keep the data in the database itself.
Oh, hey, that's a great segue into our next section.
It's almost like we planned it.
Yeah, how about that? All right, so let's say that our social app is doing great, and we decide to create some separate rooms or forums where people can also add posts away from this main collection, maybe in a sub-collection like this. And yes, there are compelling arguments to be made that you could keep all this in the main post collection, but just humor me here, I needed a good example. And each individual room can go ahead and add their own moderator. To avoid confusion, let's call them room mods. Now, this is something that might be changing so frequently, and a user might be a moderator of lots and lots of rooms that maybe we don't want to record this as a custom auth claim. Instead, we'll add a field to each room called room mod, and that will equal the ID of the room moderator. So we want to say that a user can edit a room post if they are the author, just like before, or they're named as a room mod in the parent room document. So let's look at doing this. So I'll set up a separate block for rooms and posts within these rooms. And, realistically, given that my rooms will eventually need security rules as well, it might be nice to nest them like so. Up to you, though. Either way is fine for now. But like I said, at some point, I'm going to need to go back and add some rules for my rooms here. So like before, I can allow users to update a room if they are authors of the original post, like so. And then here's what I'm going to do. I'm going to get the document in the database that corresponds to the parent room. Then I'm going to grab the data of that document and look at the value of the room mod field. If it equals the ID of our signed-in user, then they are a moderator and allowed to edit this post. Let me explain this a little better since there are a few new concepts here. So this get call basically means let's get a document from the database. In general, get calls have to start by grabbing databases/database/documents. That's the path to the root of our Cloud Firestore database. Remember, this $ parentheses thing is basically how you do string interpolation and path arguments, even though this thing doesn't actually have any quotes. Note, by the way, this database variable is the database variable that we captured way back at the beginning of our security rules all the way up here. So then you can see that by grabbing room/room ID, that grabs the room document by using the ID of the parent room being captured here. Calling data on that document that we just fetched then gives us all those fields as key value pairs. And so by looking at room mod, we can see the value of that field. So how do we know this works? Well, heck, let's write more tests. So the basic rule to test that an author can edit their own post is basically the same as for regular posts. In fact, I'm just going to kind of copy and paste it from here. The only difference, and honestly something that I should have done earlier, is that I'm putting the entire document path into a string instead of doing the collection.collection.doc thing. Okay, and asserting that you can't edit somebody else's room post kind of looks like this. So I'll test these and, whoops, looks like I have an extra semicolon there. Okay, let's fix that. And okay, our tests are looking good so far. But now let's set up a test where you're the room moderator. So it allows a room mod to edit another person's room post. So let me break room path up into a separate variable here. And then I'll use a little string interpolation to set up our post path. For those of you coming from a native mobile background and maybe not familiar with JavaScript, JavaScript does string interpolation by using backticks for your strings and then using the $ curly brackets for this string to be interpolated. Wow, 2 string interpolation formats in one video. Don't say I never taught you anything exciting. So first, I'm going to have our admin Firestore set up a room document where our user is set up as a mod. Then I'll create a room post belonging to good old their ID. Then I'll go ahead and grab a test instance of our database, access our test document, and assert that editing this document succeeds. Let's try it. And hey, it all works. Excellent. And this is great, but in most real-world situations, rooms don't have a single moderator, they have several. So let's assume that instead of having this room mod field equal to a single user ID, our room documents can have a room mods field that consists of an array of user IDs. So I think this is a simple enough change. Let's go back to our security rules and we'll change room mod to room mods. Then, how to change this? Honestly, I can never remember if this is like contains or index of or what. Luckily, a quick Google search for Firestore security rules reference gets us there pretty quickly. In security rules land, what I think of as arrays are officially known as lists. So if I click on this doc, it looks like it is the in operator we're interested in. And it looks like there's some other interesting functions we might want to refer back to at a later point. These might come in useful. Anyway, let me go back and change this to request.auth.uid in this thing. And then let me rewrite this last test here. I'll set room mods to a list of mods, and that can include our user along with, say, a dummy user. And let's run it again. Hey, how about that? It works. But this is kind of an awkward looking security rule. It's already starting to look a little unwieldy and confusing. So let's extract this into a function called userisRoomMod. I'll define the function right up here. We'll do a little copying and pasting, and we're done. Now I should note that where we write this function matters. By keeping this function here inside our room block, it still understands what room ID is. That capture is available here right outside. If I wanted to move this outside of this block, say by putting it up here near the beginning of my file, that would work, but I would need to explicitly pass in room ID here. And if I want to place this function completely outside of this block, well, that would work too, but then I would have to pass in the database variable as well. Kind of up to you what style you prefer. I generally like having my functions close to the thing they're testing for, even though it's kind of less clean visually. So I'm going to put it back down here, but it's really a personal preference at this point. You do whatever you like best. And how do I know this refactoring works? Why, I can rerun my unit tests. And look at that. Thanks to our growing repertoire of unit tests, I can feel fairly confident that my code still works. Okay, let's move on to some fancier things we can do with security rules. And we'll start by adding some rules to create a post. This was something we kind of glossed over earlier, but we should really go back to it here. So let's go back to our plain old top-level post collection. Forget the rooms for now. And let's start off by saying that you can create a post as long as you list yourself as the author. No masquerading as other people. This is pretty easy if you make use of the third piece of data that developers often use when writing security rules, the request.resource object. Now, the request.resource object is very similar to the resource object, except that it represents the document you're looking to add to the database or the document in its post-updated state, whereas the plain old resource object represents the document that's already there. And just like the resource object, you can get at the key value pairs inside this database document by looking at the data property of request.resource. So let's put this into practice. So we will allow users to create a document if the request.resource.data.authorID equals request.auth.uid. So this is saying you can create a document if the author ID of the document we want to write equals the verified user ID of our signed in user. Now, the tests here aren't all that interesting. We'll create one to make sure you can create a post if you do list yourself as an author, and one that fails if you try to add somebody else as an author. So we'll run these and great. But let's move on to a more interesting feature. What if I want to require fields? Like maybe every post has to contain an author field, a content field, and maybe a couple others. How about like that visibility field we talked about earlier, and maybe a headline? Well, let's start by adding a function, post has all required fields. And we'll define it up here, and let's see, how should we write this? The verbose way of doing this would probably be to list out every single field like this and require that it not be set to null. But I already hate this, and I hate myself for typing this out. But I think the rules reference docs can help us out here. If I look at the page for resource, which is the object you get back from request.resource, you can see that the data object is a map. A map is kind of like what you might call a dictionary in iOS land or a hash in Android land. And if we jump to the map reference docs, I can see that it has this function called keys, which returns all the keys in that map as a list. So first what I'm going to do is grab request.resource.data.keys. So I have my keys as a list. And as you recall, lists have a few methods you can perform on them, one of which is hasAll. As the name suggests, this will return true if the list has all of the values in another list. So I can say that if my list of keys has all of this list of required fields like so, then my function returns true. This looks good. Let's give this a test. I could write one test where I have all the required fields and another test where I don't. By the way, if you're freaking out because I'm reusing the same post document over and over again and are worried I might be performing an update instead of a create here, don't worry. Remember, I have that before each function that clears out my database before every test. Anyway, let's run my tests and, oh, that's interesting. This test I had earlier, it fails now. And that's because it's missing a couple of my required fields. So let's fix that. Oh, let's also add these fields to other earlier tests so that I know it's failing for the right reasons. So we'll test these. And that's better. All right, so let's go back and refactor a little bit. I'm not a huge fan of these big old one-line functions like this. And it just so happens that security rules has a somewhat new feature where I can create temporary variables within a function using let. So if I were to let required fields equal, and then let's just cut and paste this, then we can use that variable right down here. Now, I kind of suspect that behind the scenes, security rules is just doing like a simple hard-coded replacement when it comes time to compile, since I think these values are immutable, but it still makes my code easier to understand. And if I rerun my tests, everything still works. Again, refactor with confidence, thanks to security rules. Of course, often with security rules, it's not just about requiring that a document have a bunch of fields. Very often, you'll want to declare that a document can only consist of fields that are within a particular set of approved fields. Now, they don't all need to be required, but you also don't want your users creating fields outside of this list. For example, let's say that we want to allow photos, locations, or tags for our posts in our social app. Now, we don't want to require them, but we want to make sure they're allowed, and we also want to make sure people can't add documents with fields that are not on this list. So let's find out how to do that. So let me go back into my rules here, and let's create another function, post only includes allowed fields. So let's see, how would this work? Well, I suppose one way to do this would be to just write out all of my keys like this. And then instead of using request.resource.data.keys has all, I could change this to request resource data keys has only. I'll add a call to this function down here. And honestly, this would be enough to work. In fact, let's whip up some tests to prove this. Here we go. You should know how to write these by now, but pause the video if you need to copy them. So this is okay, but I'm not crazy about having this mix of required fields and optional fields all in one jumble like this. Between this and the function above, I feel like I could easily get my field lists out of sync. So step one, let me start out by going back and splitting this list up into required fields and optional fields. That'll make further refactoring easier later. Next up, I'll create an all fields list by concatenating my required fields and my optional fields, and we will check for that instead. So let me rerun my tests. Whoops, missing a semicolon. Let's fix that. And okay, now it works. And now that I've done that, it seems like this is a pattern I would use pretty often in my security rules. Maybe I can make this a more general purpose function. So let me create a function up here called document fields checkout, where I'll pass in a required list and an optional list. And now I can create an all fields list like so. And then I can say return request.data.keys has all of my required fields, and request data keys has only that list of all fields. And then go back down here and remove my call to the original two functions, and I'll just make this a document fields checkout call. I'll add back my list of required fields, which I now only need to list once, and my list of optional fields. And then I can go back and delete these two functions. So I think this should all work. Let's run these tests again. And yes, that all looks good. Okay, let's move on to another related security rule. Let's say that we want to allow users to edit their posts, but I'm going to be strict here. I'm going to say that after a post has been created, the user can only edit the content and visibility fields and nothing else. So how do we support that? Well, let's give it a try. At first glance, you would think that this would work very similar to our rules for creating posts. So let's start by creating a custom function called edit only changes fields, and we'll pass in an allowed list of fields. Maybe we'll want to say that the request.document.data.keys has only allowed fields. Then down below, we'll add on to our update function by saying what we have before, and edit only changes fields. And we'll pass in visibility and content. And let me make this clearer by wrapping some parentheses around this part. By the way, note that the grouping of our logical arguments matter here. Right now, we're saying that even a room moderator doesn't have the power to change the author ID or the headline. That's something we could change if we moved our parentheses around. Anyway, this seems like a reasonable rule, right? So let's test it. So we'll say that we can edit a post if we are editing the allowed fields. First off, I'll go ahead and use the admin Firestore app to create a post with all the required fields. Then I'll grab a version of the app signed in as our author, and then I will call update and attempt to update the content. So let's try this, and oh wow, looks like I broke a whole bunch of tests, all of which involve editing a document. So clearly something is wrong with this new function I wrote. For some reason, request.auth.data.keys doesn't have only the set of fields. I wonder what it does contain. Well, if I were writing this in a traditional language like JavaScript, I'd resort to some good old-fashioned console debugging here. Unfortunately, I don't have that option available to me.
Wait, you do?
Oh, really? Tell me more.
there's a new function in security rules called debug. You can wrap debug around any statement in your code that you want to evaluate, and it will go ahead and print out the value to the log while still returning the value.
Wait, what do you mean by still returning the value?
Imagine you have if 5 plus 5 equals 10.
Oh, slow down there, egghead. Let me think for a second. Okay, go on.
Right. So if you turn that into debug 5 plus 5, that would still evaluate to 5 plus 5, but it would also spit out that value to your log. So if debug 5 plus 5 equals 10 still evaluates to true. And you could even say something like debug 5 plus 5 equals 10, which would print 10 as well as true to your log. Got it?
Got it. Okay, time for some simple print debugging, my favorite kind. So going back to my function here, I'm going to wrap debug around request.resource.data.keys to see what I get. I'll run my rules again, and of course they still fail. But now let's go back into my test directory, and I'm going to open up firestore debug.log and see if we can figure out why. Let's jump to the bottom here. Well, let's see here. Looks like I have a list of values, and it contains 4 fields. Not just the content field I tried to edit, but also the visibility, headline, and author ID, which aren't on my list of allowed fields. But that's kind of weird, right? Like even though my request is to only change one field, my request.resource.data object contains multiple fields. Hey, Rachel, why is that?
So the reason this is happening is that this request.resource object doesn't just represent the changes that you're trying to make. It represents the entire document as it would look after the update. So even though you're only changing the content field, the request.resource.data object contains the content field you're looking to change, along with the unchanged fields from the original document. We refer to this as the document being hydrated.
All right. Now, there's certainly times when having a hydrated document can be useful, but in situations like this, where you only want to know what's changed, it can make life tougher. So the old school way of fixing this would have basically been to iterate through every field in your document and explicitly say that, for instance, resource.data.authorid equals request.resource.data.authorid, and that resource.data.headline equals request resource data headline, and so on for every field in your document that's supposed to remain unchanged. Oh, and don't forget the null checks. Ooh, what a mess. So you can kind of see why developers quickly grew to dislike the solution. So there's now a much simpler solution, one that involves a powerful new security rules language feature called the map diff. So if I go back to my function here and look at request.resource.data.diff resource.data, what I get back is this object called a map diff, which basically represents everything that's different between these two maps of key value pairs. And if we were to take a look at the documentation for the map diff object, you can see it has a number of useful functions. You have an added keys to get a list of keys that have been added, removed keys and changed keys, and also affected keys, which is basically a superset of those 3 other functions. This will give you a list of all keys that have been added, removed, or modified. Actually, to be more accurate, it gives you a set, which is kind of like a list, but it has no inherent order and can't contain duplicate items. Still, you can use handy functions like hasAll and hasOnly and use those against other lists or sets. So if we were to say that affected keys equals request.resource.data.diff resource.data.affected keys, well, now we can say that affected keys has only the allowed fields that we passed into this argument. All right, now I think we're onto something. Let's give this one more try. Oh, hey, look at that. All my tests pass again. But to be sure, let's also add in a test where we try to edit the headline and it fails. And actually, before I run my test, if you're curious what this map diff object looks like, go ahead and add a debug around it. Oh, also, if you end up using debug like multiple places in your code and maybe get confused as to what's displaying where, a fun little hack I found is to go ahead and just let some unused variable equal debug and then a big old string announcing what it is you're about to display. So when you do this, security rules will rightly complain that this unused variable is going unused, but what are you going to do? So when I run my tests again, and you know what, let me tail-f this thing first. Okay, now when I run my tests again, you can see my map diff values are being printed out in the logs, which is nice. Okay,